Good evening, or good afternoon, or good morning, depending on the time that you're listening to this. So our team was enhancing smart agriculture, and the members were Dr. Delphine, Samson Nooko, Olive Dushime, and Paula Heza. We also had research assistants who were assisting us in the field. So the problem basically is the problem of post-harvest losses that are experienced in Rwanda and food insecurity, and also excessive use of fertilizer by farmers that leads to degradation of the environment. So we saw an opportunity where the government is able to support, and also a ready market for a solution that will be able to help farmers to improve in their product. So we came up with an offline IoT-based TinyML-driven solution. And with this solution, the device is able to collect soil nutrients, pest, and diseases data from the field. Then models are applied to be able to determine the fertilizer that is able to be applied, or the pest and diseases that have been realized, and give real-time alerts to the farmers on what actions they can be able to take. This solution is customized for the Rwandan market, and we've been able to collect data. We went through a research design where the first sprint included field surveys. 10 farmers in Bugesera district were interviewed, and from that we came up with the journey, stakeholder, and empathy maps that guided the study. And then later, in the second sprint, we did data analysis, then we did persona building, and also came up with ideas for the prototype. So from the data that we collected and the analysis, we came up with the two personas, that is the traditional farmer with no agricultural education, and the modern farmer with agricultural training. And in the third sprint, we did our low fidelity prototypes, and we had 3 prototypes and had focused discussion with the farmers, and we were able to improve on the prototype, and our prototype was able to evolve. In the first one, we were able to add an additional language, remove crop prediction, and also integrate forecasted weather. Then we also further divided the prototype into 3, where we had soil analysis, fertilizer recommender, and disease predictor separately. And for this, what we were able to do with the support from Sacco Innovate is prototype the soil analysis and fertilizer recommender. And this had the ARM Cortex as the MCU. And then we have the soil NPK sensor that is able to get real-time data from the soil. And then based on what has been gotten, make recommendation on the LCD for the farmers to be able to see. So I'm going to show you now the practical application, microcontroller and others. Then that is the NPK sensor. And this is connected to a computer where we are also able to see the output as we were testing how the application is able to operate. And then since the sensor is not put in the soil, you can see that the readings that we are getting at this point are 0, 0, 0, meaning that the sensor has not been put in the soil. And you can also see the same output coming out from the screen. And the recommended action is for all the components to be added, that is potassium, sulfate, nitrogen, because basically it means that there's no fertilizer in the soil. So the system is recommending that all the components of the NPK should be added. And as you can see that N is 0, P is 0, and K is 0. Now we are going to do our test and try to plug in the sensor into the soil. So we do at different points, given that a farm also has different points, and trying to get different readings. Once that is done, you will see a difference on the screen showing something different and different readings. We have 24 mg per kg, 25, and even 60 respectively for the 3 components. And you see recommended action here is potassium sulfate. This is basically shows that the level of potassium is low in the soil sample that we had collected that is intended for planting of maize. And so the system is giving a recommended action. You can see the values that are there. And basically we use a study that guides on the levels that are needed of different fertilizers for every given soil. And so that is basically a brief working of how the system does.